So, hello everybody, and welcome to my part of the session today in today's Data Summit. My name is Bernard Schinkowitsch. I'm based in the today not so beautiful city of Vienna because we have a thunderstorm outside. But yeah, so for those who are not known where I am, I'm based in Vienna, in the heart of Europe. You should by now see my screen. And Vienna is in Austria, and we are very famous for some cliche topics like Wiener Schnitzel or the New Year's concert or the Lederhosen. And with a lot of cliches, they are only partially true. So we have also some very decent industry in Austria, and I happen to have worked with a lot of them. I'm looking back now for at 30 years around of manufacturing experience, starting at Siemens, for example, which is kind of like the General Electric of Europe, and then automotive industry, energy industry, and for the last 10 years, I'm doing projects, digital transformation projects with a lot of companies in the region. My topic today is what I have learned so far in this last 10 years and even more since the pandemic about common challenges of manufacturers and how to solve them. So I will touch today on what are the problems on ideas in manufacturing. Why do they have such a hard time to scale? And what is needed? How can we help those great ideas to scale, to be rolled out to different regions, to different lines, to different devices, and leverage and multiply business benefit coming out of data? And what are those common data-related challenges I mentioned before? I have, in the last year, around about 150 talks with manufacturing managers, and I'd like to share what they all share about challenges they have and how can we help them to generate savings and value out of those. And to say this already up front, edge computing, edge platforms, connectivity, data modeling will play a major part in those solutions. And at the end of my part, I'd like to show you then some examples of use cases we have successfully delivered and which are day in, day out producing value for the customers mentioned before. So coming to the first part, maybe you have all experienced so far that you had this one great idea that could really change how you produce today and change how you generate value and multiply your savings. And then you managed even to get the funding for a proof of concept. And let's say the proof of concept was even successful, and then it didn't scale. I think we all know such kind of projects. You have experienced them by yourself. And why is this? Why proof of concepts sometimes don't scale, although they were successful? Just imagine being in an automotive industry in a body of white production where they have hundreds of robots doing spot welding, meaning to weld parts of the body in white together. And you come to the point that you say, okay, let's do a common monitoring for those welding spot robots and put everything in a dashboard to see what we can improve. And we really find out, okay, from this 40 stops you have over your hundreds of robots in your production, you find the reason why these stops happen. And you can then reduce, in an ideal world, to 0, as you see here. And although this proof of concept was successful, it doesn't scale. You put it into the POC landfill. And why is that? Why do you waste that money? Why have you wasted time? Why have you lost this opportunity? It's because in detailed view, data is very different from devices which appear on the first glance even the same. And why is this so? You might have and you will have different models and different makes of machines in your production. You will have machinery from different vendors. For example, you will have FANUC robots, ABB robots, or universal robots. And they might even have different protocols and variants of protocols, meaning although they do all the same, they share the same workload, they look very different on a data, from a data point of view. And that's why POCs often don't scale, although they are successful. And this is the worst thing that can happen, because you had this good idea, it worked, but you cannot leverage it. And there are some things you can do, even starting very near at the machine, to mitigate such failings of POCs. And you will hear a lot during the course of today about different possibilities how to do that. One is to reduce the complexity of data variants, of machine variants already starting on the edge. And this is actually, you have three ways to do that. The one thing is you start and hope that your machine and equipment provider is doing the standardization for you. So you take the data as it comes and hope that it comes in the protocol or form that you can then afterwards process it. But yeah, all of us know that hope is a poor strategy. The second way how you can approach the data harmonization, data normalization is you do it within your use cases, you do it within your POC, which means that people have from time to time to discuss again and again about what's the single source of truth, what does this data actually mean, they are seeing, and so on and so forth. And this means also when you do the data normalization, data harmonization within the use case itself, you have repeated efforts. And this is maybe, or not maybe, but surely one of the reasons why proof of concepts do not scale. The proper way how to do it, and I recommend to you to start with that, is to do data normalization, data standardization very close at the machine, there where the data originates, and you have still the domain knowledge. What does this data mean with respect to your process? This enables you to successfully upscale your proof of concepts to further equipment or lines. You can start to do cross-organizational training because the meaning of your data is clear, meaning training of analytics models. You can reuse existing analytics models because once a machine can do a task at hand, you do not have to take care about differences in data because you have cared about that up front. And you can start to use proof of concepts and solutions across the whole enterprise. And this is not only something that we say from a manufacturing services and IT services company. This is also something which a lot of modern data architectures are now doing. Modern IT OT architectures are now leveraging, and also our one of our key partners in manufacturing area, the automotive company Renault, does it that way. For example, what we did for Renault is we have connected over 22,000 machines of their shop floors in more than 40 locations, and are generating through that and the use cases which are leveraging this normalized data. We are creating double-digit million savings per year together and for Renault. So it's worthwhile. It doesn't come for free, but it has a huge benefit to look into data at the very beginning, contextualize it, normalize it, and then when it goes up towards your IT and OT systems and to the cloud, that it has already a meaning, and you do not have the discussions about what's the single source of truth, what does this data mean, and how do your use cases use it to create value. That being said, what has this all to do with edge computing? So I also already mentioned before that modern data architectures have this level where they normalize and contextualize data at the very beginning of very near to the data source. And this is how a very simplified architecture, modern architecture can look like. And what you see here is there is this edge layer, which you will hear a lot about today as the presentation goes on. And this edge level is becoming more and more important, because with that you can do this, as I said before, data normalization, data contextualization, so to make sure that the data has a clear meaning, and use cases which use the data can leverage it and can scale. And what this edge layer also does, and there are numerous platforms out there, of which Litmus is one, and also our partner preferred for the region. With modern edge platforms, you will reduce complexity considerably with the connection downwards, which means southbound, and to handle and manage the complexity of machinery, as well as the northbound connection to your on-premise system, be it the ERP system, be it the manufacturing execution system, or a maintenance quality system, you name it. Both sides are very effectively simplified with standard connectors, with guided applications, how to onboard a machine, and with powerful tools to contextualize and normalize data. So to make sure that once your business use case comes into play, you want to do predictive maintenance, you want to do welding spot detection, as mentioned in the beginning, that your welding robots look the same from a data perspective, and you can apply whichever use cases, whichever training model, whichever dashboard you have for those robots to all the robots you have in your enterprise, because you have taken care of the data normalization up front. And this is also helping to leverage even more your assets and your use cases, because once you have trained machine learning and analytics modules, you can use them on the edge, deploy them here on the edge in order to do streaming analytics. So really, before something terribly goes wrong in your production, because maybe a tool breaks or a machine is a turning machine is driven outside of its maximum characteristics, then you can do something about it because you know it. This was in the previous presentation, was this status slides which Jake mentioned. How's the machine health? Is the machine running within normal boundaries, or is there a problem, and then I need to do something about it? And all of this is leveraging and creating value to do more with data, to use data in more ways, because you have normalized it, and to connect any machine, any cloud. This can be done very easily with modern platform solutions, modern edge platform solutions. So what are now challenges that are common in production? You hear a lot about analytics, you hear a lot about artificial intelligence today, about ChatGPT today, but the reality in production does still look very different. And what a lot of companies still are challenged with is that they need to do the groundwork still of data connectivity, data modeling, data normalization, in order to have a proper entry point into analytics and into AI and leverage those modern tools. And you can look at the left side for yourself and see which one of those challenges that are true challenges, which are still out there in productions, which one apply to you. And I just had yesterday the presentation where I showed this slide as well, and my counterpart told me actually all of those apply to us in some sort of form. So there are still unconnected machines out there, or controls which are not well connected, or just provide a limited amount of data for production. There are still companies which simply do not know their machine state, they do not know the health state of their machinery, of their equipment. There are different data sources out there, different protocols, different platforms on-premise and on cloud, which drive complexity even further. Important process data is sometimes not known. There are people going back and forth in the production to manually take down vital process data and then put it into an Excel sheet, which then needs propagated further. There is an widespread experience out there that machine connectivity is cost intensive, it takes long, and it is complicated, which with the right tools is no longer the case. There's also the experience out there that it's hard to create benefit out of data, and integration with IT and OT and business logic creation is something which companies feel is complicated, and they want to have support. And still, there is little experience with analytics, ML, and AI in the market. And although there are the tools available, and you can even sometimes map the tools directly to the problem, companies find it hard to create the business value needed or projected or proposed. And even though it might be created one time for a POC, they find it hard to scale, as said before. And that's why what we created is what we call the Eviden Value Factory, to exactly fill this gap you see in the middle between tooling and the challenge ahead. And it's very easy from the tooling side to connect any sensor these days, any sensor of over 15,000 out there within seconds, and put the data on a local data broker or put it in the cloud, or both. There are platforms out there which can connect out of the box 250 to 300 different programmable logic devices, so-called PLCs, out of the box, also in minutes. Machine connectivity is now done within hours, not within weeks. You have you can expect the first insights into data within days, not within weeks. And also machine learning AI building blocks are available out there. Once you have this data structure topic in solved, then you can have easy access to pre-trained models and analytics. So the world becomes much easier through edge platforms and through standard connectivity platforms. But this is not all which is needed. Said before, you can connect very easily each sensor which is out there. There are tools to connect to every PLC, to every machine, to every cloud, to every on-premise system. So those boxes are out there, just configurable. You do not need technical knowledge today to connect a single machine. But this will not do the trick so far. This will not produce any business value so far, because then you have the data, and so what? So what you also would need is this analytics tools, frameworks, dashboard topics, integration into your third-party systems, and also some applications which help you to bring all the things together and create, for example, when you have an anomaly detection of a machine, that you create an incident in an ERP system, that you deploy then the maintenance guy who takes best case an app with him on a smartphone, goes to the machine, does the diagnostic, takes some pictures and reports it back, either for adaptation of planning in the production or for maintenance and spare part ordering, or even you might have the proper spare part available, exchange it at the machine, and you're good to go again. And this business logic, which needs to bring everything together, is something that you can also very easily do today by leveraging low-code, no-code platforms and robot process automation. So the tools for our disposal are here for our disposal. We just need to bring them properly together in the way that we focus first on the business problem and then on the technology. But keep in mind, for all the connectivity issues, be it southbound or be it northbound to the hyperscalers or to the on-premise systems, this is very, very effectively taken care of by edge platforms, and you can then furthermore leverage them as well to apply from the top left here, for example, analytics and machine learning modules for streaming analytics and improvements of your production. So what did we do so far with such kind of tools? And this is also something which Litmus is exceptionally good at. You can, within 1 week, you will have first insights about an overall equipment effectiveness, which is a key performance indicator of productions today. Not within months, within weeks, you have first insights, and within 1 or 2 months, you will have the first improvements. And we improved customer OEEs by 5% within 2 months, which is when you have a level around of 80%, which is quite good already, which is an enormous improvement. Anomaly detection is also something that a lot of edge platforms and also Litmus have out of the box. So you do not, once you have your data available, you do not need to employ a data scientist to program and establish anomaly detection. This is today a building block which needs just to be configured in order to work properly. And then you can rest assured that once that your machinery is in a green working mode, meaning that it's operated within normal boundaries. And once something goes wrong, you will be informed immediately, not too late when something happened and the machine is damaged. Maybe. What we also do is indeed is machine health for example, for compressor motors. I've learned recently that compressed air is one of the most expensive, let's say, production ingredients you have. So you want to make sure that your compressors are running properly. Also, we do that also for ventilation systems. Energy management is something which came into focus recently with the energy crisis coming up, and for that also an on-premise system where you can put in the process data with sensors and sense also the energy which you are consuming in order to have that process running. Gives you vital insights to reduce energy consumptions, and this is especially interesting for steel producers. There we managed to reduce by 7%, which is not meaning kilowatts, but megawatts of energy per year, which this customer saves. Remote monitoring alarming. There is with an immediate alarming and dispatching of maintenance staff, you can up to 20% reduce the mean time of response when something happens, and this gives you a head start to make sure that everything is properly running again and up again before your production stops. We reached this 20%, for example, for a wind park. And there are more things to come. For example, tool life prediction is something we are currently working on. There we use edge platforms and sensors to generate with machine learning and AI so-called virtual sensors. So what we are doing here is we predict the tool life of a milling machine within a precision of minutes based on what's there, which data is there from the PLC and which energy is consumed, which means we do not apply a specific sensor for that, but we use the data which is there and create what we call a virtual sensor driven by analytics and AI. And this is something which is especially nice because if you do not need to apply a sensor, sense this given, to achieve this given task of tool life prediction, this very easily scales to thousands of machines, and we are just in the process of doing that. So that being said, coming from why do POCs not scale? Why is it so hard to solve these connectivity issues and to make use cases scale? To the point, what's needed to be done on this last slide. So what we recommend to you, what we advise you to do is, and as a takeaway for today, we advise you to enable scalability of data-driven solutions by data standardization on the edge. So very close to the equipment, there where the meaning of the data is very clear, where the domain knowledge is still here. Then to reduce any connectivity or data-related challenge, the complexity of it, by utilizing modern edge platforms. You will hear a lot about it today in the presentations to come. And to accelerate value creation by composable solution building blocks, like, for example, an analytics framework, low-code, no-code tools for the business logic, and robot process automation to automate recurring tasks and rule-based tasks. When you do those three things, and they sound very down to earth, they sound very, let's say, no-brainers. When you do that, you will have data with a meaning, you will have scalable use cases, and you will have user interfaces and simplified work for the people you have on your shop floors and in your offices. I'm open to questions. Thank you for your time, and have a productive meeting today as it goes on. Thank you very much.